for me, this is just a vacation for my daughter and I. But I feel bad for all the other people that are having to compete with an astronaut during the lectures. I don't know if you saw that go on board. If you want to see an astronaut, I think they have one talking from space about zucchini or something. Anyway, okay, so let's get to this talk here. So piecewise regression analysis establishes a breakpoint for the Botanist effect. Now this Botanist effect thing is, what is the Botanist effect? This is an old paper, it's 13 years ago. I actually wrote a response to the criticism of this paper, but the reviewers didn't like it because one, they said my response was on a local scale, because at this time, really only UT and a couple other places had their herbarium database. But also the bigger problem is they didn't have specimens that were geo-referenced. So really the databases, what you could actually do was access collections by county. So you could have like a county number of how many species or how many herbarium specimens were in a particular county. But over time, this has grown, and so you see now I'm in a position to actually respond to the reviewer criticism, but it took like 12 years to be able to finally respond. So what is the Botanist effect? The Botanist effect, counties with maximal species richness tend to be home to universities and botanists. But I want to pay attention, this right here is the problem. What they were looking at here is species richness, and you'll see what I mean. So their argument here is Mormon Estabrook demonstrated for an 80-year herbarium distributed throughout the U.S. that plant species richness was highest in counties with their herbarium and significantly lower in neighboring counties without herbarium. They coined this phenomenon the Botanist effect. But there was a response to this by these individuals, Patasso and McKinney. And their response is the Botanist effect revisited plant species richness, county area, and human population size in the United States. And so what they were actually arguing is that what Mormon and Estabrook saw was that areas that had high species richness was simply because humans had a tendency to actually settle in ecotones or areas that are going to have more species. So they're saying, well, that's not really an effect of botanists. The reason why there's more species is because humans just like to live in places with more species. So again, they demonstrated that the higher species richness is positively correlated with human population size. Their suggestion humans are driven to settle in areas with higher species richness. So again, what you have here is you have this chicken and egg argument. Which came first? Well, the species richness because botanists are describing that, or the human population moving to areas of high species richness. What I mean by actual versus observed is that one criticism I would make of this paper, even though I agree and understand what they're trying to say, is that they were actually looking at species richness guys as though they were correct, as though they were the real thing. Whereas these two papers are making more of an argument that this is just the observed richness that you see. And it seems like a nuanced distinction, but it's an important one. So, how best to address the chicken and egg argument? Well, the phenomenon in question is called the Botanist effect. The data used to support this effect is species richness. However, botanists do not collect species richness. Instead, they collect herbarium specimens that are in turn used to calculate species richness. So I think a better approach to this would have been to actually look at herbarium specimens and not look at species richness. And we all know this is the Preston's or collector's curve. The collector's curve indicates that species richness value increases per county with an increase in herbarium specimens or sampling effort. However, once the asymptote is reached, the exponential increase in species richness outweighs with the additional sampling effort. So we do see that, yes, herbarium specimens can help to use to calculate species richness. But again, like I would argue, we should be looking at this instead of this to report this Botanist effect. So if you were to draw that more like this, you would look like, well, you have the human population. Some humans that are botanists collect herbarium specimens, and God bless them, because there are lots of very great people that collect plants that are botanists. And I know working when I was at the University of Texas, you had people that were sending specimens from all over the world. It was fantastic. Some humans also write florists. One of the best florists I've ever seen was written by a lawyer. And some humans are botanists. So then if we look at this, some botanists again collect herbarium specimens, some botanists then write flores, and then some botanists again report species richness either through plots or whatever. So if we look at this, if we look at the flow chart like this, or going, how do we get to species richness, I think this a little bit kind of represents it more to the point. So this is various regressions. It doesn't matter. I read this from Mexico. You know, the more herbarium in a state, the more herbarium specimens. The species richness values decrease with the accumulation of herbarium specimens. Again, we know that the larger the human population, the more herbarium specimens that are collected. More bodies in an area, the higher the species richness. Large, anyway, it just kind of just keeps on going, but I was just kind of looking to sort of pinpoint what are more of the metrics that help to drive herbarium herbarium collections. But this was a paper that I wrote with a colleague of mine. At the same time that that Botanist effect paper came out, the only problem we made is we didn't give it a cute name. We didn't give it any name. But we actually demonstrated that really what we were looking at herbarium specimens. So this paper demonstrates for the state of Texas that counties with herbarium had higher documented species richness and also herbarium specimens than counties without herbarium. So again, we were showing that yes, this is kind of more closer to this Botanist effect of saying, well, we have more herbarium specimens in areas that we have botanists and herbarium, which makes perfect sense. But again, this really isn't enough to demonstrate it. This is a regression curve of the number of herbarium specimens per variant to the number of botanists. So again, the more botanists an herbarium has, we can see here the number of herbarium specimens increases. Not necessarily because they're always collected, but maybe because also they're just processing specimens. That's my problem. I'm sure a lot of people are guilty of this. We've got lots of collections that are from 20 years ago that are still sitting in the case that you haven't really mounted yet or anything. So it's not enough to collect. We've got to actually see those specimens make it to the to the actual general collections. So when addressing the Botanist effect, it is perhaps best to evaluate herbarium specimens and not species richness. I will test the Botanist effect by measuring the proximal effect of herbarium distance on herbarium collecting. So in order to do this, I will need to locate herbarium that have georeferenced their herbarium specimens. Then I can test the hypothesis. If the Botanist effect is an actual phenomenon, then the number of herbarium specimens should decrease as distance from the herbarium increases. And again, this took a long time to do because it took a while before we saw lots of herbarium around the world having their georeferenced their specimens. Now, one of the first places that did this was Mexico, from generous funding from the government of Mexico, as well as, I don't know if you know this, but Jose Pinero, I think he's always embarrassed when I mention this, but he's a botanist at UT. His father was the president of Bacardi, and so Bacardi helped to sponsor some of this. Like, he was a great mentor to have, because when you collected in Mexico, you got to stay at the Bacardi mansion. And that was lots and lots and lots of fun. So, yeah. Anyway, so what I did here, so then I just isolated the herbarium specimens from this particular herbarium, the Jalapa herbarium. So herbarium at Jalapa, then I measured the number of specimens at 10 kilometer increments, using the ARC map, this Cregan effect, so every 10 kilometers calculate the number of specimens. So if we look here, a total of 150,000 specimens, approximately 20% of all the database Mexican specimens. The further specimen from Jalapa was 1,300 kilometers. So we can see at these increments that 10 kilometers or 20, we see these numbers right here. So then the next test is I ran this to what they call this piecewise regression analysis. And this is a regression tool that helps to look when you're studying independent variables that partition the clusters into separate line segments, or rather what it can help to do is it can help to find a breakpoint. People use this for measuring pollution from a factory. What's the breakpoint that we see pollution level drop to a safe level? You can do this like measuring the distance of acorns from a tree. I have my students do this, and we go out there and we do these incremental distances of radii around an oak tree, and they count, and we see, okay, well, what's the maximum distance this particular species of oak tree distribute its acorns. So running this data through this piecewise regression, what we see here is that for this particular area, we see about a breakpoint of about 113 kilometers right there. And then we ran this other herbarium from Mexico, so this was about 180. This one right here is about 200. This one here was about 125. This one came here about 100. And about 180 again. Now, again, I was able to do this about 10 years ago when this Mexican herbarium was georeferenced, but again, the reviewer said, well, again, it's just at this one area of Mexico. That's not enough to demonstrate it. So I had to wait. So now we've got a lot more. So now we've got Australia. And so we looked at Australia here. We looked at the herbarium in Queensland. And we can see here a breakpoint at about 230 kilometers. Melbourne, we see about 188 kilometers. State of Mississippi, we see a breakpoint here in the varying places about 122 kilometers. Arizona, since we're here, we got about 260 here, we got about 180, 114. I got a whole lot more of area now that have just been stacking up over time, because I figure, okay, let's just inundate it with data from all over the world now and just publish it this way. And so if you look at this now, this was my first attempt to do this back like in 2008 or 9. But the problem is this was done by the number of herbarium specimens per county and not actual location. So again, the distance of 10 kilometers wasn't going to work because one particular county could be larger or smaller. But overall, you still see the same effect. The numbers are a little bit shorter in distance though when you use entire counties instead of actual specimens, georeference. So we just get a kind of a general idea here. Entire region about 62 to 100 kilometers. Individual vary about 113 to 230 kilometers is the range I've found so far. You average this out about 175 kilometers. So data for the numerous geographic areas, the sources confirm that indeed a spatial bias in their variant collection exists. Now we all know this. This is nothing new. But I think what's fun and what I find most interesting here, and again I do this because again if you're faculty and you're teaching, you know that at some point you got to find research that you can data mine and do while you're sitting in your office hours where no student ever comes and you're sitting there for 3 hours and like that. I might as well do something with my time. Let's just go and do this mind-numbing work of which I have to go count the number of specimens for each 10-kilometer increments. But so like I said, sitting in that office hours gives me plenty of time to do this. So botanists really show a bias towards collecting closer to herbarium, and I expect most key professors can tell you why this is. I mean, if you think about this, if we're looking at about 180 kilometer breakpoint, we'd see that maybe 100 miles. Well, that's probably about the max you can do in a day, right? Enough to wake up early, you drive somewhere, you collect your pants, you drive back home, because over time it gets expensive getting hotel rooms, eating out. So, or plus you also have to, you don't teach on Wednesday, but you got to teach on Thursday. So you go do your collecting, you come back. So again, I would suspect that most of this is done because what a botanist can do in a day. So the threshold distance is about 180 kilometers, like I said. Here's the map of all the herbarium, at least in Mexico and the continental United States. So if we put this, do this buffering of 180 kilometers around this, we can look at these black areas as what I would suspect to be your areas with low species, specimen collecting. And again, why is this important? Well, let me tell you, I got to do a sabbatical in Mexico. I always tell my students, if you're going to study a plant, you might as well study one that's on the beach, right? And look at this little area right here. See this? This is Banderas Bay where Puerto Vallarta is. And that Puerto Vallarta fell right outside that 100-kilometer area. I was able to make a good argument to my university. Well, see, I didn't go to Puerto Vallarta to collect plants because no one's cut the plants out there. It actually turned out quite well because I found lots of disjunct species from Costa Rica and from the Yucatan. So indeed, there really hasn't been done much outside of the city itself. So in a way, maybe this could be of effort to people writing grants or something, because it's not enough to say, hey, I want money to go, like I said, live in Puerto Vallarta. Maybe now we can establish some sort of metric as why it's important to get funding from particular sources as to why you want to get hotels or why you need rent-a-cars or whatever it is, so you can travel further from your herbarium to help get all these gaps. This is a different paper I wrote at Collector Bias where I actually use species area gaps or species area curves to determine these gaps. So the red areas are well collected, and so again the white areas are well collected. So it kind of works at the same sort of pattern here, even though the species area curve way I think is a lot better to actually get, because you're comparing predicted versus observed values. Here I'm just saying, okay, this area probably doesn't have much collection simply because it's 180 kilometers from an herbarium. Solutions encourage students to collect, perhaps as part of undergraduate research. I mean, your work right there in Beaver is way outside of what we see in this range, which is good. Promote collecting in areas outside of the kilometer. Encourage statewide database collections, which everybody's pretty much doing now. Run models of that areas and do by spatial gaps. But here's the most important one to me is to redefine the definition of the botanist effect, which actually includes specimens and not species richness, because again, to look at species richness doesn't get you anywhere. You get into a circular argument here. And this is a quote that I like from 1768. Again, the individual that pointed out this collector bias, it is, I find, in zoology as it is in botany, all nature is so full that the district produces the greatest variety, which is the most examined. And again, it makes sense where you have more botanists, that's going to be where the examination is. Thank you very much.